Alright guys, welcome back to another Math Notes. Today we're going to be talking about exponents. This is section 1.2.1. This should be a fairly quick review of exponent laws with a couple examples and then some problems for you to work on. So in the expression x to the third, x is the base and 3 is the exponent. Let's take some look at this, some examples here and different laws. So if we have two exponents with the same base or two expressions being multiplied together with the same base and different exponents, we get to just add the exponents. In other words, if we have x to the third times x to the fourth, we can just add 3 plus 4 and get x to the seventh. Similarly, if we had 2 to the fifth and 2 to the negative first, since the bases are the same, they're both 2, we can just add the exponents and say 5 plus negative 1 is positive 4. In the same vein, if we are dividing two expressions with the same base and different exponents, we can just subtract the exponent in the denominator from the exponent in the numerator, subtract the bottom from the top. So we would have x to the m minus n. For example, if we had x to the 10th divided by x to the 4th, then it would just be x to the 10 minus 4, x to the 6th. If the larger number is on the bottom, if the larger exponent is on the bottom, I should say, then you'll end up with a negative exponent. So this is 5 to the 4th over 5 to the 7th. We do 4 minus 7 and we get 5 to the negative third. If we wanted to make that into a positive exponent, we could do 1 over 5 to the third. Alright, when we are multiplying or when we have an expression with an exponent raised to another power, so power to a power, we are going to multiply. So x to the m raised to the n power is just going to be m times n. It can be useful to sort of think about the parentheses here, meaning multiplication, although that's just kind of a little visual shortcut. So x to the fourth raised to the third power is going to be 4 times 3, or x to the 12th. 10 to the 5th raised to the 6th power is the same thing as 10 to the 30th power. Little definition here: anything raised to the 0 power equals 1, as long as x itself does not equal 0. So if we have any old giant expression, if it's raised to the 0 power, is going to reduce to 1 there, so it's going to simplify to 1. Sort of a reason for why that is based on our previous laws. If we had y to the second over y to the second and we subtracted those two exponents, we'd get y to the 0, which would give us 1. And also, back from previous courses, if you have the same number over itself, you can put a big 1 there. That reduces to 1 as well. So 9 to the 0 is just 1 also. I mentioned this up above right here when I said 5 to the negative 3 could be 1 over 5 to the third. If you have a negative exponent, you can make it positive by moving it to the opposite side of the fraction bar. So you may say, Mr. Jewell, there's no fraction bar here. Well, we know that x to the negative m is really x to the negative m over 1. And to make that positive, we move the x to the negative n down, and it becomes x to the positive n, and there's a 1 on top now. So x to the negative 2, move it, remember that's over 1, move it to the opposite side of the fraction bar, and it becomes 1 over x squared. 3 to the negative 1, move the 3 down, it becomes 3 to the positive 1. We don't even usually write that, or just 1/3. And I'm going to throw in my own little example here just because they don't have it. If you had a negative exponent on the bottom of the fraction, if we had, say, and I'm writing with a mouse here, guys, so bear with me here. If we had, like, say, 2 to the negative 4th on the bottom of our fraction, so 1 over 2 to the negative 4th, that's the same thing as 2 to the positive 4th, because we're going to move that up to the top of the fraction. Finally, last rule, if we have a base being raised to a fractional exponent, what we're going to do is raise that base to the m power and then take the nth root. So as an example, if we had x to the 4/5, we would say x to the 4th power and then take the 5th root of it. With the number, that means we would take 8 to the 2nd power and then take the 3rd root of it. So 8 to the 2nd power is 64, and then take the 3rd root of 64, which in this case would be 4. So see if you can use these rules to simplify the following problems and have those ready to talk about in class tomorrow. All right, guys, have a good